Today we have very important topic. We'll learn how data is stored in Java programs. We'll talk with you in details about primitive types. Also we'll discuss what variables are. After this lesson you will have all necessary knowledge regarding primitive types to proceed with your Java education. We'll start this lesson from theory, and after that we'll play with primitive types and variables in Eclipse. It will be very important to understand how you can convert primitive types between each other. First of all, let's try to understand what data types are available for us in Java, how we can store information in our programs to be able to work with it in the future. There are two major groups of data types in Java. They are primitive types, reference types. Reference types consist of classes, annotations, interfaces, enumerations, arrays. We will not discuss reference types today in the lesson, but we will talk about them later in the course. Today we will talk about primitive types. They are integers, floating point numbers, booleans, characters. Probably you're already interested. What is the difference between primitive and reference types? There are many differences between them, and we will learn all of them as we keep learning Java. But the main difference is that primitive variables store the actual values, whereas reference variables store the addresses of the objects they refer to. The primitive types in Java are analogs to the simple types found in most non-object-oriented languages. If Java object-oriented language, why then we still need to use primitives sometimes over objects and reference types? There is only one reason for this. It's efficiency. Making the primitive types into objects would have degraded performance too much. As you become more mature programmer, you will find how to use properly primitive types and reference types. But right now, let's review each primitive type in detail. Here is the table which will help you to learn and understand all primitive types. You can find next columns here: type name, size, minimum value, maximum value, and wrapper type. Primitive wrapper class is wrapper that encapsulates or wraps primitive data types so that these can be used to create objects. Why do we need this? Objects might have their own behavior and methods. We will use objects in Java collections, for example. The simplest example is that primitive type int just storing value in the variable. Integer not only storing value, but has its own behavior. For example, integer object can compare itself with other integers, which provides necessary application programming interface to create self-sorting collections. This is just one example. From this table you can see that main difference between simple integers is the amount of memory allocated for the variables. This also impacts value range of each primitive type. Taking into account that data in computer stored in binary format, the amount of bits allocated to the variable tells us what range of data we can store in it. We will learn number systems in the next lessons, and you will understand why in 1 byte, which is equal to 8 bits, we can store values from -128 to 127. You can see that 2 bytes allocated for short, 4 bytes allocated for int, 8 bytes allocated for long. If we are talking about floating point numbers, then we need to know that for each float variable 4 bytes are allocated, and for double 8 bytes are allocated. The interesting thing how much memory we need to allocate for boolean value. The right answer would be here that size of the boolean is platform dependent. Why? Because to store true or false, which in binary format 1 or 0, it's enough even 1 bit. The problem is that not always you can reserve exactly 1 bit for the variable. Most likely this will be 1 byte. Characters. We need characters to be able to describe all symbols of Unicode. Cyrillic, special characters, etc. We have 2 bytes for char primitive type. This gives us the range from 0 to 65,535. Each value will represent the sequence number of character according to Unicode table. You might be wondering why short type also have 2 bytes allocated but have different range of values. In Java you can't declare signed or unsigned variables. This is managed on JVM level. So char has the same amount of bytes allocated, but just because it's unsigned, it has different range. Probably you already heard that Java is strongly typed language. Part of Java's safety and robustness comes from this fact. What does it mean? It means that every variable has a type, every expression has a type, and each type is strictly defined. Also, all assignments, including parameter passing to the method call, are checked for the type compatibility. The Java compiler checks all expressions and parameters to ensure that the types are compatible. In case of any type mismatch, programs simply won't be compiled. We will also learn in this lesson how type conversion works in Java. So what is variable? Variable is a piece of memory that can contain a data value. You can see that each variable has data type. Even when you create variable with var keyword, compiler identifies type of this variable. For the variable name, usually used nouns started from the small letter. You can't use keywords for the variable names. What are keywords? For example, int, byte, short, class, public, package. These are all keywords. Keyword is a word with a predefined meaning in Java programming language syntax. I will share with you a link to all keywords after this lesson so you could learn them. There is no need to go over each of those right now. Now let's practice. We'll take a look how to declare variables of specific types in Java. For this lesson I created a new class with name primitive types in the package primitives. Let's declare a variable of specific type. Byte b equals 1. So here is variable declaration. Short s. And here is variable initialization. S equals 2. You can declare and initialize variable in one line. Int I equals 3. Long L equals 4. Let's proceed. Here is a char variable. Char C equals A. You can notice that characters literals are annotated with single quotes. Boolean literals only true and false. Boolean bool equals true. And now let's create float variable. Float f equals 1.2. Compilation error. What's wrong? If you would hover over value, you will see the reason. The issue is type mismatch. Can't convert from double to float. You should know that floating point number literals by default has type double. And you can't convert from double to float because double requires more memory allocated than float. Does it make sense now? To tell compiler that this is float, we are using F letter. You can use capital F letter if you wish, that would mean the same. Talking about types of literals, it is worth to mention that all integer literals has int type by default. Let's have a look at this example. Long L2 equals 2 billion. By the way, you can see that you can separate digits with underscore to increase readability. You can see that there is no error right now, because int literal is still within int range. But let me add few more zeros here. And you see compilation error. Why? Because literal of type int is out of range. What to do in this case? Just tell compiler that this literal has type long. How? Just put L letter at the end like this. Let's also create double variable. Double D equals 1.3. As you can see, there is no errors here. Previously we discussed that you can declare an initialize variable with var keyword like this. Var v equals 1. In this case, compiler will help us to identify type of this variable. So after first initialization, you can assign only integers to this variable. You can't assign boolean or floating point numbers, because this variable has int type right now. And now we'll run primitive types conversion. When we are talking about primitive types conversion, just keep in mind boxes. You always can put smaller box into bigger one. That means you can always put value of 2 bytes into 4 bytes. Int i3 equals s. S is short here. You can put the value of 1 byte into 4 bytes variable. You can also convert int to char. Char c2 equals 100. In this case, char variable will be initialized with character which has sequence number 100 in Unicode table. Let's check what this character is. Systemout.println C2. This would be D character. The same conversion rules are also applied if you have double variable with 8 bytes allocated and you want to assign to it int which is 4 bytes. Double D2 equals I3. You can assign 8 bytes long to 8 bytes double. D2 equals L. All conversions examples which we just saw are examples of widening conversion. In most cases, widening conversion happens without losing data, with some exceptions. A widening conversion of an int or a long value to float or of a long value to double may result in loss of precision. That is, the result may lose some of the least significant bits of the value. In this case, the resulting floating point value will be a correctly rounded version of the integer value, using IEEE754 round to nearest mode. If we would talk about narrowing conversion, it can't be done automatically. For example, if I would try to assign int variable to byte variable like this, b equals I3. We see here a compilation error because compiler can't convert int to byte. What we can do as programmers, only in case when we need this, we can tell compiler that we know what we do, and tell compiler to calm down and we are sure that this is byte. Just type in parentheses byte. You can do the same way with all other narrowing conversion. You might be wondering, if all integer literals have int type by default, why we don't have compilation error when we assign int literal to byte like this, byte b2 equals 10. We don't have compilation error because compiler can read literals value during the compilation process and identify that this value is within the byte range. But if we would add additional zeros here, we would see compilation error. Now I can put byte here, but what would happen if I would try to print byte to console? Your best guess? Sysout b true. This situation called overflow. When an integer overflows, it rolls over to the minimum value and begins counting up from there. You know that max positive byte value is 127. Let's put 128 here and see what it would print to us. Minus 128. Be careful with conversion from double to long. Even despite 8 bytes allocated for double the same as for long, the integers and floating point numbers stored in different way in memory. Conversion from type double to type long requires a non-trivial translation from 64-bit floating point value to the 64-bit integer representation. Dependent on the actual runtime value, information may be lost. That's because floating point numbers and integers stored in different way in Java memory. Let's consider this example. We have this long number. Let's convert this value to double and then back to long. Do you see the difference between long and double converted back to long? Just take this into account when converting long to double and vice versa. And probably the last thing which I would like to cover with you for today is autoboxing and unboxing. At the beginning of this lesson you saw that each primitive type has its wrapper type. Autoboxing is automatic conversion that the Java compiler makes between the primitive types and their corresponding object wrapper classes. For example, integer i4 equals 1. So here you can see that int was autoboxed to integer. If the conversion goes the other way, this is called unboxing. Int i5 equals i4. Here you can see that integer was unboxed to int. And now let's recap what we have learned today. After this lesson you know what primitive types are, what variables are, You know rules for conversion between primitive types, and you saw what autoboxing and unboxing is. And now your homework. Read books, read chapters about primitives, learn Java keywords, and take a look at Oracle documentation regarding primitives conversion.